Alright, good day everyone. In my last class, I explained isothermal system. In this class, I'll be explaining polytropic system. Polytropic system. A polytropic system is a system that allows both the transfer of heat and work, and this is what differentiates a polytropic system from an adiabatic system. Adiabatic system does not allow the transfer of heat. Now, in a polytropic system, there is a polytropic process, and this polytropic process fulfill an equation, and the equation is PV raised to n must be constant, where n here is polytropic index. Polytropic index. This equation contains all the systems that we have been discussing so far. It contains the isochoric, the isobaric, the isothermal, and isentropic. And I'm going to show you how this equation governs all these systems. Now, PV raised to n is constant. When n, which is the polytropic index, is equal to 0, it simply means PV raised to 0 must be constant. And then V raised to the power of 0 is 1. It means I'm going to have P is constant. This is showing that pressure is constant. And when pressure is constant, we could remember vividly that the system is called an isobaric system. So this is isobaric. Also, when n is equal to 1, I'm going to have PV raised to 1 to be equals to constant, showing that PV equals constant. And when PV is equal to constant, it's basically telling us here that temperature is constant. And this is for isothermal system. Okay? Let's check the other ones that we have. Remember, PV raised to n is constant. Now, when n is equal to infinity, okay, I substitute that into the equation. I'm going to have P raised to infinity is constant. Okay, and if I multiply the power by 1 over infinity, I'm going to have P raised to 1 over infinity, V raised to infinity times 1 over infinity equals constant. Then P raised to 1 over infinity, V raised to 1 is constant. 1 over infinity is 0. So this is P raised to 0, V raised to 1 is constant. And P raised to 0 is 1. So we are left with V is constant. And when V is constant, that is isochoric system. Okay, now the other one that we have is when our n is equal to gamma. Gamma is adiabatic ratio, which is always equal to Cp over Cv. I'm going to explain this in my other lecture. Okay, and then if I substitute this into this equation, I'm going to have PV raised to gamma is constant. And when this is achieved, the system is called reversible adiabatic system or isentropic system. Isentropic system is a system with constant entropy. Entropy is the rate of disorderliness in a system. Okay, so we can now see that PV raised to n equals constant, which is the equation for polytropic process, govern all other type of systems that we have in what? Thermodynamics. All right. As if that is not enough, PV raised to n equals constant can also be expressed in terms of temperature. And how do we achieve that? Okay, all we have to do is, we know that our PV raised to n is constant, and then from the general equation that we have under chemistry, so we have to recall that P1 V1 divided by T1 is equal to P2 V2 over T2. Okay, and then from here, if I make my P1 and P2 the subject of relation, I'm going to have P1 divided by P2 equals V2 T1 divided by V1 T2. Okay, and then now we come back to this equation, which is PV raised to n is constant. Okay, this is basically saying P1 V1 raised to n equals P2 V2 raised to n. And if I make P1 over P2 the subject of relation, I'm going to have P1 over P2 equals V2 raised to n over V1 raised to n. Okay, then this is P1 over P2 equals V2 over V1 all raised to n, rule of indices. Now, if I equate this to this, that shows that I'm going to remove P1 over P2 and substitute this. In that case, I'm going to have V2 T1 over V1 T2 to be equals to V2 over V1 all raised to n. Okay, then I can transfer this to the other side. And if I'm doing that, it simply means I'm going to have T2 over T1 equals V2 over V1 all raised to n times V2 over V1. Okay, so basically what I'm doing here is that I divided both